Okay, hello everybody to our statistics course B in this semester, or econometrics B. First of all, some organizational issues. For these of you who don't know me already, I will always make parallel Zoom meeting in this lecture if it works, hopefully. And I also will upload my lectures on YouTube. And for the content of my lecture, you find the organizational part in the Moodle course, but the content you will find on my webpage. And here I also have one for Statistics B. So here then I will successively upload all the slides, links to videos, and additional material. But the conversation and so I will use Moodle and the announcements via Moodle, and something which need not be in the internet. This then I will also put in the Moodle course. But I think the most relevant, the content, you will find on my web page. So what else? Yeah, I call this not econometrics but statistics B, because yeah, if I would start now directly with econometrics, then we would need to know what is testing, what are hypotheses, what is significance, and so on. And I would doubt that you already know what this is about. So I could do it and say, well, you have your introductory courses in statistics, but I don't think that it would be a fruitful lecture then if I would start with this. So in the beginning, I will just do a very quick review of what is a statistic variable, what is an expectation value, what is variance, and so on. Hopefully, most of this you have already heard. Then also for describing some distribution, I will give you some further indicators which we use in statistics. And then I will start. I do it in my introductory courses in statistics, but this is what you need in econometrics. You need to know what is a regression, because what you are more or less doing in econometrics, you say I'm a macroeconomist, so here is economic growth, and this economic growth of an economy depends on inflation, on unemployment, on whatever, on the demographic situation in our country. So you have many causes for some variable you are interested in. This is called then the independent variables, and you want to know what mean these independent variables for your dependent variable which you want to explain. And this is generally done via multiple regression, and we will especially look at the multiple linear regression. So we will start with a very simple model where we have only one independent variable and one dependent, the simple linear regression. And when we have talked about this, then we will go to the multilinear regression. And then also we can do a regression for everything. Well, always there will come something out because this is still only descriptive statistics. But then we want, so to speak, know how good is our regression. And for this, we have to do then hypothesis testing. Then, for example, we assume that only with a probability of 5% we are wrong. And then we want to know, fit our data within this hypothesis, that I make only an error with 5% probability. And this hypothesis testing we will then also do together, and further on we will do also some other time series analysis, also descriptive time series analysis. So yeah, this will hopefully be a general overview. And what I also want to do with you is analyzing data directly in the software package and especially in Excel, because of course Excel is not the best statistics software package. There are many much better software packages, but on the other hand, you're not studying mathematics or statistics, you're studying economics. So Excel is where you always have access to. When you are going then later on to some company and you say, well, I'm an expert in SPSS, doing analysis, and maybe this is not a large company, but medium size, and then you say, well, the license is 1,500 euros. Then maybe they say it's nice that you can do it in SPSS, but we won't buy this software package for you. And I think most things in statistics, what you will do maybe in the future, I think all things you can do in Excel. And there are also many add-ins for Excel doing statistics. And so I also want you to start doing analyzing data with Excel, and therefore yeah, please, if it's possible, and most of you have it, just bring into class your laptop, your iPad, your tablet, and you have, I think, 3 access to Microsoft Office as a student, or you can apply for it and then download it, or most of you will have it on your laptops, but also if you use something like OpenOffice, LibreOffice or something, there also the syntax is more or less the same like in Excel. So when we are doing exercise, something will be theoretically, but also we will do it then directly in Excel, because also, well, of course, I can do with you a linear regression, taking a calculator and then typing all in the numbers. Well, if you have only a data set with 10 data points, this is possible, but it takes you maybe 15 minutes, half an hour to put all the data in your calculator and pressing enter and writing everything down by hand. But on the other hand, a software package is doing it for you directly. And I will do it in a medium way, because what you can do in Excel is, and this I will just show you. Oops. Let's say these are two time series, X and Y, at time 0 and 1, 2, 3, 4. Then you can plot, yeah, you see it, this data in an XY diagram. So my processor is going down. Hopefully it doesn't crash. But now it is. And then, for example, you can click on the data and just fit in the regression line, and then he has done for you the linear regression by just doing 2 or 3 clicks. Of course, this is possible, and if I show it to you, then you can also do these 2 or 3 clicks. But what I want from you to understand, what are you really doing by clicking on the data? And so we will take the data in a format like this, and then we will 1 or 2 times really directly type in the formula which we need. Then also the formulas for statistic formulas are also directly implemented in Excel. I will show you also this, like calculating variance, calculating expectation values, and so on, so that I want you in this course to learn to really use this software. And if you then have later on a data set that you don't say, oh, this will take long time to analyze it, that you in this course maybe have learned, well, I can do it in one afternoon or something like this. So this as a general announcement for this course. So since this is an English lecture, I will not change the language in my Excel program, because then I have always to shift it back when my lecture has ended. So you will find here then the German formulas, but here I gave you also a link that if you want to use the English version, that you directly find the translation for Excel for the English names of the formulas. But this you can change here, I think, in options. Down here, there you can change in Excel the language. But you have to be careful when you change to English, because comma and point then also exchanges. And if you have a date and you write 3rd of September with a point. Then in the English version, it is interpreted in another way than in the German version. And this problem you quite often have when you download data from the internet. Then quite often this is formatted in the English version, and then you have in data the number separated by a dot, and if you download it in the German version, then it is interpreted as a date. And for this you also have to be careful when you just switch between the languages. Okay, what else? Yeah, if you want to contact me, the easiest way is just to write me an email, or from Monday to Thursday, mostly I have lectures, so you will find also me in my office opposite of this lecture hall, because all my lectures will be situated in this room here. If you have longer things, then we can also set up a Zoom meeting, WebEx, what else? We all have learned this during Corona, how to work with this. Okay, done. Of course, some overview for literature. So since this is a lecture, then something in between, I have a repetition of an introductory course, more or less, and then going a bit further, especially by doing time series analysis. So most of what I'm talking about here, you will find in standard statistic books. And here are some, and I also found some with this doing statistics, especially for business and economics. Also the next one, mathematical statistics, Newbold, and the last one down here is then, since we will have a large topic about doing linear regression, this is then direct a book for linear regression. Then in this course, the exam form will a classical term paper. We will talk about this in a minute. And there I want you, to deal directly with some theoretical part of time series analysis. You will see this in a minute when you see the topics. And for these topics, you can, more or less directly rely on these 3 books. You see, all these deal especially with econometrics, and what you should do then is more or less redoing there some small chapter from these books, and you should show me that you have understood what you have written down and what you are talking about in these books. I tried to buy these books for our library. I found that the first 2 and these are the more important one. You find these 2 books already in our library, also as e-version, I think. So this is the one. Do we have here the e-version? This is 2004. This is an older one. There's also a German version. This you can also use. So I didn't see it right now here, but from the Guide to Modern Econometrics, there I verified that we have also the ebook. And here is a stereo, and why there is no things. But there we should also have the e-version, and what I cannot do here in this course, but if you just type in Google these books, you will also find maybe not the newest version, but an older one as a PDF version in the internet. Okay, so then we will go to the term paper. So I show you then in a minute the topics, and tomorrow we have also this was wrong in the first version. So then we will tomorrow assign the topics you want to choose, and not that long, 10-15 pages. It could be even less than 15 pages. So it's more a theoretical part which you should do at first. What you can then do when you have explained all the theory, you can of course also look for some examples also, but this won't be the main part. So let's say 10 to 15 pages. I think you can manage this to do it. Well, for the literature, I don't know if you have already written term papers. Some of you were in the global economics. You said it to me. I don't know. Have you already written term papers in your studies? Uh, I don't know how you have dealt there with sources and literature. For me, I take it easy, but because I think what is the need for a bibliography? It serves for the purpose that an interested layman can find the specified source as quickly as possible. So take just a book or a scientific paper and look how they have done it there. Start with the author, then maybe the year, then the title, but also, of course, you can change this, but then it has always to be the same way. That I'm not somehow puzzled. I want to read it. Where have you find this? And I want to find this as fast as possible. Question? Yeah. Hmm? Yeah. 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 Well, then you can just send me which topic you want, and now we are 5, 6, 7. I think we will manage this, and maybe you can also talk to your colleagues. Um, After this lecture, I want to take this topic or so, and maybe then we do not have to draw lots tomorrow. But yeah, yes, each person has to take one topic. Yep. Again, this is a term paper, and maybe you have also other exams, and during the next week, then you see, well, maybe it's too much for me, then you can step down from the exam until the end of October, until 29th of October. And if you want to do this, just write me an email. So not in the online data of the examination office. This is not relevant since it is a term paper. Your lecturer is relevant. He has to know if you want to participate in the exam. Submission is then 27th of November, also as an email, or maybe I make it uploadable in Moodle. You will see this. And if it's then an email, then please keep in mind that we have restrictions in our email accounts, that the file is less than 10 megabytes. Yeah, the literature will be mainly the books I showed you, and then you can go further. But of course, the main part, the theoretical part, you will directly find in these books, and then you can go further and especially for look for examples you can use for this. Then this I forgot in the other lecture this morning is that I also want you in the end of the lecture to present what you have done, and this I want maybe to do at this weekend, 15th, 16th of December. And for this, I also want to go to a youth hostel just here at the coast. Sitting then together, and well, I don't know if we can do this. I have also who has to pay for it because I don't want that you pay. I have to see if I can finance this. So direct question, is this possible, or have you already planned to be in holidays at this weekend, Friday, Saturday? Also the question into the internet. So this is the last weekend of the lecture time. And we would then also jointly do this with the term papers in global economics. And then we have in yours was 7, and here also 7:14. Yeah. So Friday, Saturday, this should work. Maybe we can do also then a Wattwanderung or something like this in the evening. So it should not only be at this weekend only to sit in a room, because this we could then also do at the university. It should be a bit more. Okay. Then, yeah, we go to the topics, and I will just go through these topics. You can then, of course, have also today an additional look. What does this all means? Well, the first 3 things are, yeah, some general problems which you have in econometrics in data series. So multicollinearity, collinearity just means more or less that you don't know which was first, the hen or the egg. So you have an idea which you keep in mind. This is the independent variable and this is a dependent variable. But again, take an example from macroeconomics. Of course, private consumption has an impact on economic growth. But if you remember, private consumption is 55% of our GDP. So of course, economic growth has an impact on private consumption. And yeah, these problems you have to deal with. The second one, heteroscedasticity. This means if you then want to know something about what I was talking about, how good is my regression? So this hypothesis testing. Is my data reliable on the hypothesis that I make only an error with 5 or 10% probability? For doing this, you have to make assumptions. And one general assumption is, and this you know maybe from an introductory course, that your data is randomly distributed and that the distribution behind this is then in the limit the normal distribution. Have you heard about the central limit theorem in your introductory course? Yep. Everybody? Central limit theorem. So this is maybe, yeah, the theorem why we can do statistics. So because in general, if we have data, then we don't know the distribution. So if you go just downtown in Wilhelmshaven and you ask 100 people, because and the question is, would you buy some specific product? So you make some market research. So well, then you have the answers of these 100 people. Well, this is quite good. Then you know what these 100 people, if they would buy it or not. But what you want to do with these questions, with these 100 people, you would then think of, well, these are 100 people of Wilhelmshaven. Is it then possible to take the medium answer of these people and then say, well, since I ask 100 people, I could say that more or less all people, 80,000 inhabitants of Wilhelmshaven, would act in a similar way. But of course, you don't know what is the distribution of these 80,000 inhabitants of Wilhelmshaven. And then the central limit theorem says that it doesn't matter which distribution it is if the number of your random sample is high enough that in the limit every distribution moves towards the normal distribution. And the normal distribution, I hope that everybody heard about the normal distribution. So this was, let's go here. Oop. No, it doesn't work. Why not? Well, it's not working now. Oop. Then let's do it like this. Hmm? Why is my pen not working anymore? Hmm. Let's see. Drawing. Now it's working again. Good. But the pen is not working. Okay. So I think you know this curve of the normal distribution and the density function. This was f of x is 1 over square root of 2 pi e to x minus mu over sigma squared. This formula you have seen? Maybe. Well, you will see it in this course. So this is these very prominent distribution, and why? Because we find it everywhere in natural processes. We call it the normal distribution. And well, then we assume in general that every variable has the same variance and is normally distributed. Well, in practice, this will also quite often not be the case. And how to deal with this problem. This is the second topic. And the third general topic is that, of course, a variable is dependent on the variable itself. Our growth rate this year depends on the growth rate last year. And this is then the problem of autocorrelation. Well, the names of the topics seem quite complicated, but these are standard problems. You find this also in every standard book about time series analysis. So it is not that hard to do this. Then the fourth topics is the so-called AMA processes. This is then a general process which you assume in time series analysis, average moving averages. This maybe you have also done in descriptive statistics. If you have a time series of your revenue in a company for the last, let's say, 20 years, then what you sometimes are doing is you take always the mean of the last 5 years, so to speak, and then you have a moving average, which is moving then always 1 year, but you're taking always the average of the last 5 years. Standard method, and with this moving averages, you then can also do again, time series analysis, and there, is it a good process or not? There you are doing the so-called unit root tests. This comes also from theory, but this is also always described in the books. Just have a look there. Then always doing statistics means always, having some model in mind, and then you have in general to deal with the problem. Did I have a proper model? And can I then test my model if I have, because of the data which I feed in to my model and doing my regressions, maybe then the data says me, well, there is something wrong with your model because you have misspecified your variables. Because of course, what you are think, what are the dependent, independent variables, couldn't be, maybe it is not, you do not find this then in your data set. And then number 6 is also a general method to do analysis or to ask, do I have a good model? How good can I rely on my data? And this is called the maximum likelihood estimation. And also this goes back to our little guy, Friedrich Gauss. He invented this method about 250 years ago, I think. And yeah, maybe somebody is interested in finance, and if you look at the time series of the development of stocks, then you have the so-called CAPM model. I don't know if somebody of you, maybe you had already finance courses that you have heard about the CAPM model. Yeah. Yes, and maybe you could something explain to your colleagues? Uh, No, doesn't matter. Okay. Mhm. Yeah, how they could be weighted, and then of course in understanding the capital market, and of course if you are an investor, then you are interested where is the price tomorrow, and you want to have an idea. And the CAPM model is, so to speak, the standard model for the capital market if you look at the stock exchange and the development of stock prices. And of course, if you want then to make a quantitative forecast where are going the prices tomorrow, then of course you also have to do statistics. And this you can do with all these standard methods of econometrics. And so this is then a specific example which is worth to look at. And if somebody is interested in this. And then number 8, this is not a very new, but a quite new method. I think 5 or 10 years ago there was then the Nobel Prize in economics for this method in general, and this is the method of the general method of moments. And I already talked much about distributions. I mentioned already the normal distribution. Maybe you know other distributions like the binomial distribution or like the Poisson distribution, the exponential distribution, the uniform distribution. I don't know. Have you talked in your introductory courses about different distributions? Binomial distribution. This is more or less flipping a coin, 1 and 0. Yeah. Or uniform distribution. There you just assume that every event has the same probability. Poisson distribution, this is quite often used if you have a distribution with data points which are very seldom, which are rarely, so which are very low probabilities. Well, and of course, this is quite often then your starting point. You make an assumption about what distribution could your data fit. And the general method of moments is, I think, then something quite nice, because if you are doing statistics, you can never be 100% sure, even if your data says for 99% or so your results are good. You never can be 100% sure that you really have chosen the right distribution. And the general method of moments, then just say, well, I don't want to know exactly what distribution I have. I only want to describe as best as I can do my data. And the first two moments you already know. This is the mean. And the second moment is then data point. Here I have written it down in the normal distribution. This doesn't function. This was here. X is your data point, and mu is your mean. X minus mu is the difference between the data point and the mean, and then you square this distance. And this is the second moment. And what you can then do further on is just, where is it? There. Rise these exponents to 3, to 4, to 5, to 6. And these are then always the further moments, the third moment, the fourth moment. And if you then know these moments, if you know only the starting point is always the mean. What is the average answer of my guys downtown in Wilhelmshaven? Then you want to know how spread they around the mean. For this, you calculate the variance. But then also, it could be possible that your distribution is looking like this. So that in this part, you have much more probability math within a small interval than here on the right side. That it goes much further to the right side. And this you call then skewness. And this you can describe if you take here this difference from the data point minus the mean, not to the square, but to the third. And with this aspect, just to describe your data, with these higher moments. This is the general method of moments. So I think it is always also a very interesting topic. Okay, so have also just a look within the books I gave you to get an idea about the topics, and then maybe we can tomorrow assign the topics for your term papers. Yep. Well, the first two books here I showed you, they are in the bibliography. They are in our library. These two books. From this book, I definitely know that you have also ebook access. But if you just type in the author and the title of the book, you will directly, more or less directly, find also a version, a PDF version in the internet. And if it's not 2020 but 2015 or so, it doesn't matter. So these general topics haven't changed during the last 10 years. Autocorrelation is still the same. Yeah, but if you have problems, then maybe we assign the topics next Monday or next week, so it doesn't matter. Or if you have further questions. Okay. Yeah. Any more questions? Because now we are already almost at 11:30. So yeah, maybe I go through the general content. So we will start with a short revision about random variables and especially about descriptive statistics, the parameter of distribution. I just talked about it, what is a mean, what is variance, and then I also will introduce skewness and kurtosis. This is then the third and the fourth moment. This I think you don't have already heard about. And then as somehow a starting point also for your term papers, um, we will do linear regression starting with a simple, only x independent, y dependent, and then we will say that we have x1, x2, x3, so many independent variables and the regression to one dependent variable. In this, we will then talk about hypothesis testing. These three topics, I think we are now 7 and I have 8 topics. So hopefully these three starting topics, somebody of you will do it because then we will talk about this in your presentations, in your term papers, and I will do also with you then some other descriptive time series analysis. We will talk about so-called inequality matrices. Yeah, I just showed you here these pictures. So how to measure if it's not only symmetrical. And if you take, for example, an income distribution in a developed country, then we have there some very rich, super rich persons, and we have many more or less poor persons. This is discussed right now. If you take, for example, the 10th richest persons in Germany, they really pay 50% of the taxes of the whole tax volume in Germany. So this is then a redistribution from the rich to the poorer persons, for example. And yeah, how to measure such inequalities, or if you go to some market where you find maybe 2 or 3 very large companies and many small companies. How can I properly describe such a market with an inequality parameter? We will talk about this and then making some descriptive time series analysis, talking about price adjustment, and then I think what you always are interested when you are working in a company, what is my revenue today? This I see, and what will my possible revenue tomorrow? And in order to make such a forecast, of course, I look at the history of my revenue data. And there we will have a look on some simple forecast methods. Again, I already talked about it. Moving average, exponential smoothing, average growth rates. Oops. This shouldn't happen, but anyway, let's see. I think all of you attended my macroeconomics courses, I think. And yeah, there I talked very often about growth rates and averaging growth rates and so, and yeah, we will talk about this here again. And yeah, especially if we are look at Germany, then of course many time series are depending on the weather. We come from the summer where it is in general a bit hotter, and now it comes the autumn and then the winter time, and then of course markets changing, demand supply is changing, and then you want to know, is my change in the demand only dependent on the seasonality? I don't know, is here somebody who is studying tourism? Yeah, for sure then. This is immanent in your market. In general, we go to holidays during the summer month, and well, we go for skiing, but much less. And then, of course, as a company, you have to know my results, my revenue over 1 year. How much is it dependent only on the seasonality during the years? And there we will have a look at a simple method how to smooth our data so that I then have average data and can say for the quarters or per month, this is not anymore dependent on the seasonality issues. Yeah, this it is. And then again, I ask you, because then with the content and the short revision, what is statistics about, we will start tomorrow. Any questions? Okay. Yep. Mm-hmm. Yeah, usually I do it directly when the lecture has ended on YouTube. Yeah. Sometimes it takes some time or so, 2 or 3 days or so, but in general, I manage it that it will be available. Well, then on YouTube, it has to be converted. This takes sometimes 1 or 2 hours, but in general, it, yeah. Well, I think that global economics from this morning should be already online. Let's see if this has already worked. Because I saw that the conversion process has started and yeah, this is already online. So if this really works, I don't know, because this would be quite fast, but on the afternoon or the next day it should be available. Yeah, but will do here also yeah, many exercises and so, and this you can really yeah simply do at home or together, and then we will do these exercises also here together in the lecture. And yeah, okay.